Okay, so we are going to talk about interest. So there are two kinds of interest we're going to be dealing with. So the first kind is simple interest. So simple interest occurs when the amount of money in the account grows linearly. I said that wrong. So here's my example. You invest $3,000 in an account that pays 5% simple interest. So we're going to say, so usually you get paid once a year. So we're going to have our 4 years, and then so our amount of money starts $3,000. So what happens is the slope of our, so we're going to figure out what 5% of 3,000 is. So I'm going to take 3,000, multiply that by 5%, which is 0.05, and that gives me 150. So the 5% just means every year, no matter how much money is in my account, the bank will give me 5% of my original investment. So the equation I would use would be y equals the 5% of my original amount, so that's 5%, right? So that's my slope, times x plus 3,000. And so after 1 year, I'll have $150 more dollars. After 2 years, I'll just have $150 more dollars. And then every year, I'm going to gain $150 in my account. So obviously, the more money I start with, the more I will get paid. So if I had $300,000, right? $300,000, 5% of that would be $15,000. You see how that would grow a lot faster. Okay? Second one is compound interest. So compound interest is an exponential relationship. So we have the same thing here. So I'm going to invest $3,000. So how this works is I'm going to figure out what 5% of 3,000, that's 150, right? So I'm going to take 3,000, I'm going to multiply this by 100% plus 5%, and that's 105%, or 1.05. So my 100% plus the amount it grows annually once a year, that is going to be my multiplier. So this is my multiplier. So after my first year, no matter which account I would choose, simple or compound, I get the same amount of money. But for year 2, the exponential, I'm going to take 30,150 and times that by 1.05, and that gives me $3,307.50. So now I got to start getting change. I'm going to keep doing this. So now times that by 1.05 to get year 3, 3,472.88. Multiply that by 1.05 to get year 4. So I get 3646.52. And so, because it's an exponential relationship right here, and we've learned exponential graphs, they increase by multiplying going down the output, which is money, I can use my y equals a btdx to model this. So my a is my initial amount, which is 3,000, and b is the multiplier. So it's the 100% plus the rate of interest. And so there's a model for that result. Okay, the last one we're going to talk about is other compound interest. So interest doesn't have to be paid annually like simple in our first compound interest. It can be paid over different amounts of time. So in this example, we're going to pay that same 5% interest but monthly. Okay? So we still have years here, okay? And we still have the same initial amount. Now this is how this works. What I'm going to do is I'm going to take my 5% and I'm going to divide it over the amount of months. And what the bank does, it takes that percent and divides it evenly over the periods of time. And so 5% is, I'm going to round this, 0.417%. So this is interesting. So if I take 100%, that's less than a percent, right? So I move the decimal place over, I get so twice, right? 1, 2, I get 0.00417. So my multiplier every month is going to be 100, which is 1, plus this percent. So remember, multiplier of this. It's my multiplier right here. So my equation will be y equals my initial amount times my multiplier. Now this is the tricky part. X in this case isn't years. X is months. Because I'm increasing it, it's being compounded monthly. So X is months. If I wanted this to be in years, right, I would do this. That would multiply it by 12 times X. So 1 year would be 12 months. So I have to change the exponent if I want it to be in years. Or if I want months, I just put in how many months. So I think this one will be easier. So let's calculate. So, for instance, 1 year is 12 months. 2 years is 24, 36, and 48. So I'm going to plug these numbers into this equation to calculate how much money I'll have in that account. So here we go. So it's 3,000 times 1.00714 to the 12 would be 1 year. And that gives me $3153.61. Okay, after 2 years, I take my same equation, but now I'm going to plug in 24. I get 3315.09. Then I just keep going back. Now I'm going to put 36 for 3 years. I get 3484.83. And then I'm going to put 48 in the exponent for 4 years, because 48 months is 4 years. And I get 3663.27. You can see at 3663, 3646, I made more money, not much more, but I made more money after 4 years by having it the same amount of money compounded monthly versus annually. So that's a little ditty on interest, and essentially what you want to be able to do is take this information and create a model for that information, whether I have simple interest, which is a linear function, compound interest annually, which is a simple exponential function, or compound interest over a different amount of time periods, which is that percent divided by what period looks like. That's going to be my multiplier. I want to be able to create these models to predict outcomes and calculate values.